On July 3, 1969, just weeks before Apollo 11 was scheduled to reach the moon, the Soviet lunar dream evaporated in a blinding flash of light. The massive N-1 rocket, designated Launch 2, fell back onto Site 110 at the Baikonur Cosmodrome. The resulting explosion obliterated the launch pad with an estimated 7 kilotons of TNT equivalent. It was one of the largest non-nuclear explosions in human history. But the shockwave that destroyed the Soviet moon program did not begin on the launch pad. It began 3 decades earlier, in the depths of a political prison. To understand how the Soviet Union's most ambitious engineering project tore itself apart, we have to look at the men who built it. In March 1938, Valentin Glushko, a brilliant rocket engine designer, was arrested by the NKVD secret police. On June 27th of that same year, Sergei Korolev, the man who would eventually become the chief designer of the Soviet space program, was also arrested. Historical accounts of this period remain deeply fractured. Some sources suggest Glushko voluntarily named Korolev to interrogators in an attempt to reduce his own sentence, while others maintain that any accusations were coerced under extreme torture. Regardless of the exact truth, the damage was done. Korolev spent nearly 6 grueling years in the Soviet prison system, surviving the brutal Kolyma Gulag before eventually being transferred to a Sharashka, a secret laboratory for imprisoned scientists. There, Korolev was forced to work under the direct supervision of Valentin Glushko. It forged a bitter, unspoken resentment that would quietly fester for decades. By the early 1960s, Korolev was leading OKB-1, the primary design bureau for Soviet spacecraft. Glushko was in charge of OKB-456, the premier rocket engine bureau. But unlike the centralized command of NASA in the United States, the Soviet space program was a sprawling, decentralized web of competing interests. Different design bureaus lobbied the government for funding, pitching their own visions for the future of spaceflight. Rival chief designers like Vladimir Chelomey and Mikhail Yangel proposed their own heavy-lift vehicles and military rockets. This intense bureaucratic competition drained critical resources, money, and engineering talent away from Korolev's N-1 moon rocket at the exact moment it needed a unified national effort. In the summer of 1962, the simmering tension between Korolev and Glushko erupted into an open ideological war over how to power the N-1. Korolev insisted on cryogenic propellants, specifically liquid oxygen and kerosene. He argued they were safer and provided the high efficiency needed to reach lunar orbit. Glushko fundamentally disagreed. He advocated for hypergolic fuels, the toxic but reliable propellants his bureau had perfected for military missiles. Neither man would back down. Ultimately, a Soviet expert committee reviewed the designs and officially sided with Korolev's preference for cryogenic fuel. Insulted and unwilling to compromise, Glushko made a drastic decision. He flatly refused to design or build the engines for Korolev's lunar rocket. Cut off from the Soviet Union's most experienced rocket engine bureau, Korolev was forced into a precarious compromise. He turned to Nikolai Kuznetsov, the head of OKB-276. Kuznetsov was a brilliant engineer, but his expertise was in designing jet engines for aviation, not massive propulsion systems for spaceflight. Together, they developed the NK-15 rocket engine. Because Kuznetsov's bureau lacked the capability to build a single, massive engine comparable to the American F-1, they had to rely on numbers. To achieve the immense 45,400 kilonewtons of thrust required to lift the N-1, they clustered 30 individual NK-15 engines at the base of the rocket's massive first stage, known as Block A. Clustering 30 engines created a plumber's nightmare of fuel lines, valves, and unprecedented acoustic vibration. And because of budget constraints and the rush to beat the Americans, the Soviet space program made a fatal operational decision. They never built a ground test facility capable of statically firing all 30 Block A engines together. Without the ability to test the fully integrated first stage on Earth, the only way to find out if the complex system actually worked was to launch it into the sky. Sergei Korolev would not live to see his rocket fly. He died during surgery in January 1966, leaving his deputy, Vasily Mishin, to manage a deeply compromised program. The flight tests were disastrous. The first launch, in February 1969, failed due to signal interference and ruptured propellant lines. Historical records of this flight remain chaotic, with sources contradicting each other on the exact timeline. Engine shutdown occurred shortly past T plus 60 seconds, while the vehicle plummeted downrange, impacting anywhere between T plus 138 and 183 seconds. Then came the catastrophic 7-kiloton explosion on July 3, 1969. A third attempt in June 1971 broke apart following an uncontrolled aerodynamic roll. The fourth and final launch on November 23, 1972, succumbed to severe pogo oscillations at T plus 107 seconds. By May 1974, the Soviet leadership had seen enough. Mishin was fired. In a final, striking turn of events, Valentin Glushko was appointed to take over the program. His very first act was to completely cancel the N1 and order every remaining piece of hardware to be scrapped. The destruction of the N1 was, on paper, a failure of plumbing, vibration, and control systems. But beneath the twisted metal and shattered launch pads lay a much deeper collapse. The Soviet lunar rocket was fundamentally compromised by decentralized bureaucracy, drained resources, and a bitter personal rivalry that prevented the nation's brightest minds from working together. The argument over propellants was ultimately an argument between two men who could not escape their shared traumatic past. The N1 didn't just fail because of engineering physics. It failed because the human machinery required to build it was irreparably broken from the start.